Welcome to Lesson 18 of the AP Computer Science Saga. Make sure to have your notebook and writing utensils handy. The overall logic of MergeSort is to divide and conquer. A list of random integers will be split into two or more equal-sized lists with partial lists or sublists sorted independently of each other. The next step will be to merge the two sorted sublists back together into one big sorted list. Here is a non-recursive MergeSort method. We divide the list into two equal-sized parts and sort each with the selection sort. Then merge the two using an algorithm to be discussed later in this video. The following example will illustrate the action of a non-recursive merge sort on the selection of the list containing 8 values. Merging the two halves of the array in the modified merge method will require the use of a local temporary array. Because the two sublists are stored within one array, the easiest approach is to merge the two sublists into another array and copy the temp back into the original. This version of merge will need to be able to work with the sections of array list A, and here's the parameter list for merge. The MergeSort algorithm requires a merge algorithm that we design first. The method header and the specifications of merge method are given. Preconditions are that list A and B are non-empty and sorted in non-decreasing order. The actions are that list A and B are merged into one array list, C. The post condition is that list C contains all the values from list A and B in non-descending order. The merge method breaks down into 4 cases. Number 1, array list A is done, so pull a value from array list B. 2, array list B is done, so pull a value from array list A. 3, neither is done, so if A index I is less than B index J, then pull from array list A. 4, neither is done, and if B index J is less than or equals to A index I, then pull from array list B. It is important to deal with the 4 cases in order described. For example, if you are done with array list A, you do not want to inspect any values past A index I. Instead of dividing the list once, a recursive merge sort will keep dividing the list in half until the sublists are 1 or 2 values in length. When developing a recursive solution, the key step is identifying the base case of the solution. What solution will terminate the recursion? In this case, a sublist of 1 or 2 values will be our base case. Let's try and work through the recursive merge sort of a list of 8 values. Then the list is divided into 2 subsets. Now let's work on the left subset. It will be divided into lists of 2. Each list of 2 is now very easy to sort. After each list of 2 is sorted, we then merge these 2 lists back together into a list of 4. Now the algorithm proceeds to solve the right subset, recursively. Then the 2 lists are merged back together. Suppose that we have a list of 8 numbers. If we trace the migration of one value, it will be merged into the following size of the list: 8, 4, 2. The number of calls the merge sort needed to sort one value into its final resting spot is log base 2n. If n equals 8, then it will take 3 calls for the algorithm for one value to find its final resting spot. We must apply log base 2n steps to sort n elements in the list. The order of recursive merge sort is: what about the cost of merging fragments of the list? The merge algorithm is a linear one, so when we combine the merge sort routine, we have this, which remains in the category of this algorithm.